Welcome back to Java Internal's Crashcasts. I'm Sheila, and today we're continuing our exploration of concurrent collections. We're in the queues chapter, and we'll be diving into our array blocking queue. Victor, are you ready to unpack this fascinating implementation?
Absolutely, Sheila. I'm excited to share insights about ArrayBlockingQueue with our listeners. It's a powerful tool in Java's concurrent toolkit.
Great. Before we start, listeners, make sure you're familiar with the BlockingQueue interface we covered in our previous episode. Now, let's kick things off with a quick quiz question. In an array blocking queue with a capacity of 5, what happens when a sixth element is offered while the queue is full?
Ooh, that's an intriguing question, Sheila. It really gets to the heart of how ArrayBlockingQueue behaves under pressure. Listeners, think about the blocking part of the name and how that might come into play. We'll reveal the answer later in the episode, so stay tuned.
Excellent, Victor. Now, let's start with the basics. Can you give us an overview of what ArrayBlockingQueue is and its key characteristics?
Certainly. ArrayBlockingQueue is a bounded blocking queue that stores elements internally in an array. It's a FIFO, that's first in first out, data structure, meaning elements are processed in the order they are added. The bounded part is crucial. It has a fixed capacity that's set when you create it.
That's interesting. So it's like a buffet line with a limited number of plates, right? Once all the plates are taken, no more can be added until some are returned.
That's a great analogy, Sheila. Just like in a buffet line, if all plates are taken, you have to wait for someone to finish and return their plate before you can get one. In ArrayBlockingQueue, if the queue is full, operations that try to add elements will either wait, or block, or fail, depending on the method used.
I see. Can you tell us more about how we create an array blocking queue and what options we have?
Of course, there are 3 ways to create an array blocking queue. The simplest one takes just the capacity. For example, we might create a queue that can hold up to 10 elements. There are 2 other ways that allow you to specify a fairness policy and even pre-populate the queue with elements from a collection.
Fairness policy? That sounds intriguing. What does that mean in the context of array blocking queue?
Great question. The fairness policy determines the order in which threads waiting to insert or remove elements are granted access. When set to true, it uses a first-come, first-served approach for weighting producer and consumer threads. This can be important for preventing thread starvation, but it comes with a performance cost.
Interesting. So it's a trade-off between fairness and performance. Now, you mentioned blocking operations earlier. How exactly does array blocking queue handle situations where the queue is full or empty?
That's where the blocking nature comes into play. ArrayBlockingQueue provides methods like put and take. When you try to put an element into a full queue, the thread will block until space becomes available. Similarly, take will block if the queue is empty until an element is available.
That sounds really useful for producer-consumer scenarios. Are there non-blocking alternatives?
Absolutely. Methods like offer and poll don't block. Instead, offer returns false if the queue is full, and poll returns null if the queue is empty. There are also timed versions of these methods that allow you to specify how long you're willing to wait.
I can see how that flexibility would be valuable in different situations. Now, how does array blocking queue compare to other blocking queue implementations, like LinkedBlockingQueue?
Great comparison point. The main difference is that ArrayBlockingQueue is bounded, while LinkedBlockingQueue can be unbounded. ArrayBlockingQueue generally performs better for smaller queue sizes due to its array-based structure, but LinkedBlockingQueue might be better for very large or unpredictable sizes. Also, ArrayBlockingQueue uses a single lock for both head and tail operations, which can lead to more contention in high concurrency scenarios.
That's really helpful, Victor. Now, what are some common use cases for array blocking queue?
ArrayBlockingQueue is great for scenarios where you want to limit the number of elements in the queue, like implementing a work queue with a fixed number of tasks or a bounded buffer between producers and consumers. It's also useful in situations where you want predictable memory usage, as the size is fixed at creation time.
Excellent. Before we wrap up, let's reveal the answer to our quiz question. What happens when we try to add a sixth element to a full array blocking queue with capacity 5?
Great question. The behavior depends on the method used. If you use put, the thread will block until space becomes available. If you use offer, it will immediately return false. And if you use add, it will throw an exception. This showcases the flexibility of ArrayBlockingQueue in handling different scenarios.
Thank you, Victor. That wraps up our discussion on ArrayBlockingQueue. To summarize, it's a bounded, array-based implementation of BlockingQueue with first-in, first-out ordering. It offers both blocking and non-blocking operations, supports an optional fairness policy, and is great for scenarios requiring a fixed-size concurrent queue. Next time, we'll be diving into LinkedBlockingQueue, so stay tuned. If you enjoyed this episode, please subscribe and leave us a rating. Your support helps us create more content like this. Until next time, happy coding.